Hello class. In this video, we are going to learn how to use our benchtop NMR to collect proton and carbon signals and how to process your data. So the sample we are going to use today is ethanol, CH3CH2OH. The solvent for ethanol is deuterated chloroform, CdCl3. Now let's go to the benchtop NMR software, which is SpinSoft. It looks like a target sign. So we come here. If you're the first person come here to use it, it is probably in the standby mode. That is okay. So you're going to click on the menu sign, go back to the main menu, and click on the hydrogen. This is means proton NMR. Okay, so this will bring up a lot of proton instruments. Even if this is just a benchtop NMR, it's still very powerful. Can even do some two-dimensional NMR. But what we really need here is just a simple proton NMR. So we're going to click the first icon in this sequence, proton. Okay, our sample is loaded already. You probably learned that in a separate video. And now we're going to set up the sample name. Since this is a test, we'll call it a test. And the solvent is chloroform. In case your solvent is not a chloroform, you can click the drop-down menu and pick up your solvent you need it. Most of the time, we do 1 minute scan, but for this sample, ethanol is very, very concentrated, so we're going to use a quick scan. If your sample is not very concentrated, you can consider using a power scan to get a better signal-noise ratio. Okay, you see, that's simple. Only those parameters need to set up, right? And now we're going to click on the start button. The progress bar shows spectrum finished already. Okay, so this is the final spectrum for our ethanol in deuterated chloroform. And this one, we can process the data a little bit. So first, we would like to know the integration of those signals. Ethanol has methyl group, 3 proton, methylene group, 2 proton, and 1 active proton from OH group, right? So let's come back, see our NMR. We have 3 proton, 2 proton, and 1 proton here, but they're not integrated. So you're going to go to int, integration, or you can use auto. AUTO, auto. It will automatically integrate and label the peaks. So let's go ahead and click auto. You see, now these peaks are integrated and the numbers are listed in this table. In case you want to adjust the area, let's see, this first signal, we want to go a little bit bigger. You can click on RNT, integration. And when you put your mouse over that signal, it becomes green. So that means the signal is selected. And in this state, you can adjust the line. You can make it bigger or make it smaller. So now you can go bigger or this way, go smaller. You can even pick up the signals not integrated. If this little signal is very important for you, you can manually integrate it. Just drag your mouse over this area and it will be integrated. And the same here. But we don't need those signals, so we're going to go ahead and delete it. Click on this signal, make it green, and then click the delete button on your keyboard. That way it's gone. Okay. Now we know the first signal is a methyl group. It should have 3 protons. So we want to calibrate this number, make it just 3 protons. That will make our structure interpretation easier. So click on this signal, make it green, and then go here to the right bottom of the screen. You see there's a peak calibration value. We're going to put a 3 to this window. And now click on, after 3 is inside, click on apply. Now you see this signal is a 3 proton methyl group. This is a methylene 2 proton, and this is an active proton, OH 1 proton. So this, all the numbers are right, it's perfect. And let's check the peak picking. The peak picking, you can change or adjust it if you need it. Go to PP, which means the peak picking. this green icon on the bottom right corner and click on that. And now you see there's a red line. This is a threshold line. If you move it lower, more signals will be labeled, all those signals here. If you move it higher, less signals will be labeled, and we need those signals only. So normally your data process will stop here. We just need to label the integration and to label the peaks, but sometimes you might want to check the reference. See if a chloroform is showing up at a 7.26 ppm, is TMS showing up at a 0 ppm? Well, I'm going to show you how to calibrate the peak if the peak is not in the right position. So we're going to go back to peak picking, and now we need to show our chloroform signal. We're going to expand the signal. Use the wheel on your mouse, just keep rolling and the signal will expand. You see this signal is chloroform. Right now it is labeled as 7.384. So it's not 7.26. Let's say we want to calibrate this signal, right? So we're going to, let's get out from here. Apply that one and then go to ref, REF, reference. Click on this icon and this will bring up a red line. Now you're going to drag the red line to the chloroform signal. And now on the bottom right corner, you're going to put the numbers you wanted. Chloroform is 7.26. So we put 7.26 here. Now we click apply. Ta-da! You see, this chloroform is 7.26. And we just calibrated this signal. Now let's go back to the peak picking and bring the signal to reasonable height. Reasonable height means the tip of your tallest signal sitting around 3/4 of the overall height. So this is okay. Now we're going to lift the threshold value. We don't want too many signals labeled, make it hard to read our desired signal. And we need only triplet numbers and quartet numbers and this one. Now we click apply. Okay, now this is a fully processed proton NMR for adenol. It's beautiful with all the data and all the table listed. Now you would like to have an electronic copy of this data. You can use your phone to take a picture, but if you want a better version, you can click on PDF. This is a PDF here. So click on the PDF. This will make a PDF from this spectrum, and that is the result. You see, it's neat and clean and beautiful. Now we're going to save this PDF file. Save as. I'm going to save it to the 311 LS folder, and I'm going to call this one test adenol in chloroform. Let's call it B. Okay. So once your PDF is saved, you can go to the email account. This computer has an email account for this benchtop NMR. So if you click on the Google, the email account should be there. You can compose the email, send that NMR spectrum to yourself. So test in adenol and then put your email address here and then send it to yourself. Okay, so we explained how to obtain a proton and how to process the data. Next, we're going to show you how to obtain a carbon signal. Carbon signal is very similar to proton. So we're going to go back to the main menu and you can click on carbon. This is 13 carbon. And again, you can see a sequence of carbon experiments. And we need only the simple one. So go ahead and click the first experiment in this sequence, which says carbon. Okay, sample name, we still call it test. Solvent is chloroform, and we don't need to change anything here. So we're gonna go ahead and click start. This carbon will take about 70 minutes. You can see from the progress bar here, it says time remaining right now is 16 minutes and 50 seconds. So we will pause the video, wait 2 minutes, see how the results. The adenine sample is very, very concentrated, so we probably don't need 17 minutes. Well, let's come back to check our carbon NMR. About 2 minutes passed, and you see our sample is very, very concentrated. So even 2 minutes, we got a very decent carbon NMR. We got 2 signals corresponding to the methyl and the methylene group in the adenine. So we can stop our experiment here. We're going to go ahead, click on stop to save some time. Okay, so the same with the proton, you can process the carbon NMR. You can see the carbon is in the middle. You can bring it down here. Just hold your left mouse button and then drag it down here. It looks a bit nicer. And then you can use the middle wheel and adjust the height of the signal. And if you need, you can print a PDF and email the PDF to yourself. Okay, so now we finish the proton and the carbon NMR for your sample. When you finish, don't forget to take your sample out so the instrument will be ready for next student. If you are the very last student to finish, you can ask your lab instructor or your teaching assistant to put this instrument on standby mode. I'm going to pause the video for 1 second and then switch the sample to the standard sample that is used for the standby mode. The standby mode uses the sample supplied by our vendor, which is 5% water in deuterated water, in heavy water. So I just switch sample from our test adenine to this standby heavy water sample. Now we go to spin off, and then we go to the main menu, and we're going to click on system. Now, the system will bring up some streaming and standby and a monitor function. And what we need again is the first button here, says standby. So click on standby. And you're going to click the green button start. Okay. So when the instrument is not in use, it should be put in the standby mode. You will keep the streaming in the good value. Okay, that's everything we're going to introduce today. Thank you very much.